Impala, Flink, and more. Also, very strong industry adoption as well, with a number of companies integrating Apache Iceberg with their solutions. It's being perceived as the next generation cloud native table format for multi-engine interoperability and the petabyte scale datasets. Now, Apache Iceberg also has some very nice building feature to address performance, scalability, ease of use for dealing with very large scale data sets, such as time travel. We're going to talk about in today's presentation, partition evolution, transactional consistency, advanced query planning and filtering capability for high performance, just to name a few. So I'm going to touch these topics today in the session. So let's talk about, as I mentioned, Apache Iceberg towards the end of the day, it's a table format, right? So it is table format designed from the ground up and to be used in the cloud. And this key consideration was solving various data consistency and the performance issue when used the data located in the object store, such as S3. And Iceberg keeps track of a list of all files within the table using a persistent tree structure. Changes to a table use atomic object or file level commit to update the path to a new metadata file containing the location to all individual data files. Now, since Apache Iceberg is tracking individual files rather than folders, the expensive file listing operation are no longer needed, and this leads to performance improvement when performing operations like querying the data in the tables. The table knows which exact data files belong to the table at any given point in its history, so that I can perform time travel on those data sets. And the one important thing to know about the performance that metadata file in the file system stores partition level information as well as metrics about the data files, right? So for example, I want to know what is the min-max value of that partition. That's actually as part of metadata file in the file system instead of in the meta store in the relational database. So this is a major difference that you're going to see that, how Iceberg is maintaining the metadata. And I'm going to a little bit more detail in later slides, but just want to highlight in here, this is one of the major difference. And also there are some other performance and the scalability features that I'm going to talk about as well. Switching to the next slides is, so the Iceberg, we're going to talk about the version of metadata, right? Iceberg achieved this capability for a table via metadata files, also known as manifests, right? It tracking through point-in-time snapshot by maintaining all deltas as a table is updated over time. Each snapshot provides a complete description of the table schema, partition, and the file information, and offers full isolation and the consistency. Additionally, Iceberg intelligently organized snapshot metadata in the hierarchical structure, and this enables very fast and efficient changes to a table without redefining all dataset files. Now, ensuring the optimal performance while working with very large datasets, often at petabyte scale. Now, with Iceberg, the full history is maintained within Iceberg table format and without storage system dependency. Now, this is very important, right? And we're talking about without the file system dependency and all that. This enables open architecture and the flexibility to change the system over time without a disruption to users or existing workloads. Now, since the historical state is immutable, now this is very important, it's immutable, and the history lineage is clear. User can query prior state at any Iceberg snapshot or any historical point in time for consistent results. You can do comparison, you can roll back to rectify any issues, right? This is actually one of the important use cases I'm going to talk about later on. And also, readers, regardless of which compute engines, will always pin down a certain snapshot at the beginning of the execution, and all writers will produce a new snapshot at isolation. Now, what I'm going to do is actually spend a little bit more time on this slide since this is really the foundation piece for the Iceberg table format. The Iceberg table state is stored in the number of different metadata files which are represented in the diagram as shown on the screen. So let me describe them in a little bit more detail, right? It's very important. Number one is snapshot, right? You're going to see that on the right-hand side of the picture here is that it is state of a table at some time, at some point in time, and including the set of all data files. What it contains is actually the metadata about the table, like the table schema, partition specification, as well as a path to the manifest list. So what is, and then going down this tree structure is, so what's in the manifest list? It is file again, the file list, the list of all the manifest files. Now, one manifest list per snapshot. It contains the entry for each manifest file associated with the snapshot. Each entry includes a path to the manifest list manifest files and some metadata about the file, also including the partition stats and data file counts as well. So this stats can be used to avoid reading manifests that aren't required for an operation. And then going down, manifest, right? So what is manifest is a really listing, it will list all the data in the delete files. And also this is really a subset of a snapshot. Contains the list of paths to related the data files, right? And each entry or data file includes some metadata about the file, and also including some of the stats of per column, right? Upper and the lower boundary, and which can be used to pruning of the files during the query planning. So this is where the partition stats are stored. And also the next level is really the data files, a file that actually contains the actual rows of the table. So this is a physical data file, and in this physical data file, that this is written, it supports the file format such as Parquet, ORC, and the Evro, right? So this is the actual data file. So as mentioned, a snapshot has one manifest list. One manifest list can pointing to multiple manifests, and the one manifest can point you to multiple data files. So this is there's also a lightweight usage of a meta store in which a metadata location pointer is stored there, and always pointing to the location of the latest snapshot. Iceberg actually tracks the complete list of the data files in each snapshot using a persistent tree structure. Every update, either write or delete, produce a new snapshot that reuse as much as possible the previous snapshot of the metadata tree as possible, so to avoid any of the high write volumes. And then, so valid snapshot in the Iceberg table are stored in the table metadata file along with the reference to the current snapshot. And the commits actually replace the path of the current table. So this is actually ensures that all updates to the table data and the metadata are atomic. Now, this is really the basis for the serialization, right? So the resulting fact is that this improved the reliability as well as performance as well, so that the readers always use a consistent snapshot of the table without holding a lock. This is essentially the lockless reads that for folks that in this field, this is produce a very reliable reads, and also performance benefits, right? So since all the metadata that I need for query planning is in the file system, so it's a kind of I just read it once instead of listing all the partitions in the directory. I just read it once, all the metadata will be there, right? So this is improve my query planning performance as well, and also providing much finer granularity in terms of partitioning, the ability to do the finer granularity in terms of partitioning. So this is what we're saying, that they want to making sure that we have this foundational piece set, right? The next thing that I want to actually talking to you guys about is the Iceberg concurrency model. Now, two important concepts here for consideration. The first is what we call optimistic concurrency. Iceberg actually supports multiple concurrent writers for different multi function analytics compute engines using optimistic concurrency model, OCC, also known as the optimistic locking, which assumes that multiple transactions can frequently complete without interfering with each other while running transaction without acquiring locks on those resources. And before committing, each transaction verifies that no other transactions has modified data it has read. Now, if checks value conflicting the modification, then the decommitting the transaction rolls back and it can be restarted. And the second concept is the snapshot isolation for transaction. Now, in database, and actually in any of the transaction processing world, right, the snapshot isolation is a guarantee that all read made in the transaction will see a consistent snapshot of the database. In practice, it actually reads the last committed value that existed at the time it started. And the transaction itself will successfully commit only if no updates has made a conflict with any concurrent updates made since that snapshot. And the main reason for its adoption is, of course, for better performance. And the readers and the writers on Iceberg table don't interfere with each other with snapshot isolation. And Iceberg provides ability for concurrent writers, right, via the optimistic control. And then, by the way, all writes are atomic as well. Next, what I want to do is actually to share with you is just want to give you an example in terms of conflict resolution, right? So how actually Iceberg resolve concurrent writes. Now, in this example, there are two writers, W1 and the W2, read latest snapshot S1. Now, both adding files, modifying table state with S1 as the baseline. Now, writer 1 finished first and writes to the new snapshot S2. And writer 2 finish and try to write to S2. And guess what? Writer 2 should actually fail because a later snapshot now exists. Writer 2 retries by using S2 as the new baseline and resolving the conflict where possible. And the writer 2 can now write a new snapshot S3. Each writer will assume that no other writers are operating and writes out new table metadata for an operation. Then writer attempts to commit by atomically swapping the new table metadata file for the existing metadata file. If the atomic swap for whatever reason fails, and because another writer actually has committed, the failed writer will retry by writing a new metadata tree based on the new current table state. Next, I want to actually talk about the multifunction analytics with Apache Iceberg. Why Iceberg is perfect for the multifunction analytics. As we all know that the Iceberg is 100% open and designed to be compute engine agnostic. Any compute engine can be integrated with the Iceberg table just by integrating the Iceberg SETA library. Yes, Iceberg is actually SETA library, right? And with a processing engine. And also, this compute engines can have equal access and the processing capability and the concurrent reads and write on the common data sets, allowing for compute engine interoperability. There are a growing number of compute engines are supporting the Iceberg table format, such as Hive, Spark, Impala, Flink. Thus, if you're looking for a table format supporting for multifunctional analytics, Iceberg is the choice, and it is being perceived as the next generation of a cloud-native table format. Now, let's talk about some of the features. I just want to summarize. We talk about what is Apache Iceberg, for the past 20 minutes. So I want to just give you a quick summary of highlighting some of the main features that you're seeing, and also what kind of benefits that you can benefit from this features. Right. First is an open format and an engine agnostic. Now, Apache Iceberg is 100% open and designed to be the compute engine agnostic. Any compute engine can be integrated with the Iceberg table by integrating the set of libraries I mentioned, right, with the processing engine. So this is perfect for really the multi-engine analytics. And snapshot isolation, right? I think I mentioned earlier is that the reads and the writes on the Iceberg table don't interfere with each other, right? So you can have a one set of engine focusing on doing the ETL, writing to the Iceberg table, and then you have a one set of engine at the same time try to read. And then you will always have a consistent snapshot, consistent read. There's no, there's no dirty reads, no phantom reads. So this is what we call about the snapshot isolation. So Iceberg, because Iceberg provides the ability for the concurrent writers as well, right? And via the earlier on we talked about some of the optimistic concurrency model, and the all writes also are atomic. The next thing that is really the file level tracking, right? So we talk about file level tracking when we're talking about the metadata. It actually tracks data in the table at a file level. So it provides an always correct and always consistent view of table. And also enable very fast query planning for execution, because I don't have to go back to the meta store, getting all those, the partition level stats in order to do any of the query planning. So enable very fast query planning and execution, and also provide the user with very good response time because of fast query planning and execution without them that and also one of the things that I think I also touched upon is really the partition. The user don't have to know the actual physical layout of the data, because the hidden partitioning feature. So I'm gonna one slide actually just talk about hidden partitioning feature laid down. So this is some of the benefits that you're going to see in this file level tracking. The next thing is really the no file listing and rename operation. So what does that mean? Actually, because of no file listing, we are by avoiding the file listing and the renaming operation, Iceberg table are compatible with any object stores, right? No consistent listing is required, making it perfect for cloud native object stores such as S3, ADLS, and the GCF. So making this perfect table format for the cloud native big data. The next thing is, I think I mentioned when I talk about the meta store usage, is a very lightweight usage of meta store. So only the latest snapshot location pointer, is stored in the meta store. And so no partition level information, no stats are stored in the metadata. Iceberg can actually scale with your data set size, and the meta store is not a scale bottleneck in this case. And also, because by design, the Iceberg actually comes with some very native feature, very nice feature actually. So the time travel is the one, hidden partitioning, partition evolution are the others. What are those features do? Those features actually can help you improve your data management experience much easier. Okay, and there are some use cases I want to, some of the emerging use cases I want to share with you later on in the slide. So I want to talk about our Cloudera Data Platform integration with Iceberg, right? So Cloudera actually integration with Iceberg provides the best of the both worlds. Now, Cloudera is an active contributor in the open source community and provides a thought leadership in the many open source projects. Now, by integrating with Iceberg table format, Cloudera Data Platforms, our CDP, offers pre-integrated multifunctional analytics for advanced analytics use cases with no vendor lock-in. It also provides a shared platform for all of you, for all your existing Hive table, as well as this new open table format, Iceberg, which offers transactional support, advanced capabilities such as time travel, partition evolution, and also by taking advantage of a hybrid and a multi-cloud capability of our Cloudera Data Platform, whether data is born on-prem or data or in any cloud, can work together as a single lakehouse toward a common analytic objective. On top of it, Cloudera also enhance Iceberg by providing enterprise security and the governance capability with various compute engines that we support. Such as fine-grained access control and the lineage. So this is very important, right? So a lot of enterprise are looking for security and governance capability from Cloudera. So they want to do, the row level filtering, column masking. So we actually have that support right there with our fine-grained access control capability. So Cloudera has developed a very rich set of SQL commands for Hive, Impala, and the Spark, so that user can do very set of operations such as creating, manipulating database objects. They can run a query. And we also have a huge integration already with this as well. So they can use Hue to run the query and see the query results immediately. They can load the data into tables. They can modify data in the tables and perform time travel operation. They can also converting the existing Hive external table into Iceberg table. So we have developed this very rich set of the DDL and DML commands, SQL commands for Hive and Impala, and then leverage some of the upstream community effort on the Spark as well. So we're integrating that into our CDP platform. So this is I want to give you a snapshot what we have developed, right? So as I mentioned, it's a very extensive SQL command for Iceberg through our CDP Cloudera Data Platform integration. So this is just a snapshot of all commands that we have developed. Want to highlight here is that Cloudera actually contributed Hive and Impala SQL commands, and leverage some of the upstream effort for the Spark SQL commands as well. So we will continue to contribute to Iceberg open source community by developing more SQL commands for more operations on Iceberg commands and integrating more analytic engine with Iceberg table format and enhancing our multi-function analytics capability for the Iceberg in the cloud. What I like to do is actually highlighting some of the features that we have. This one is what we call the table conversion, right? Since Hive table format is the de facto standard for big data for many, many years, and the customer have used Hive table format for all their production system. Now we have developed the easy button utility, allowing you to convert your existing Hive external table to Iceberg table with SQL alter table command in Hive, and also some of the upstream effort also being developed with Spark 3. So you can actually using store procedure in Spark 3. You can call in those store procedure in Spark 3, converting the Hive external table into Iceberg table. And those commands are super performant commands since they are converting the metadata of this Hive external table into Iceberg table format without actually regenerating them, right? So think about if you're dealing with a petabyte scale data and without regenerating the table, that's become very, very fast just by converting the metadata itself. Now, please know that in Spark, you can either import or migrate. Import will actually leave the existing Hive external table as is, and then generate the new Iceberg tables. And the migrate will just converting the existing Hive external table into Iceberg table by converting the metadata. Next, I want to actually talking about time travel. So just to level set, right? So for folks not familiar with the time travel concept, so what is time travel? Time travel will allow users to query any previous version of the table to examine and compare data or reproduce results using previous queries. Okay, and Iceberg provides ability this time travel capability out of the box to see what does the table look like at a different point in time and use different maybe the timestamp or snapshot. I would say that this is one of the key capabilities of the Iceberg table format being actually talked about a lot in a lot of blogs and also in a lot of the YouTube videos as well. So, but there are many use cases that can really take advantage of this nice technical capability. I'm going to actually touch upon towards the end of my presentation on some emerging use cases that the customer are really leveraging this technical feature. And here is really the SQL syntax we have developed for time travel operation. With compute engines, we have integrated in CDP with Iceberg table format. Now, in this example, you can see that you can perform time travel operations with NC SQL standard as of. So we have developed based on the NC SQL syntax, right? As of, that's a SQL syntax extension that we have developed based on the NC SQL standard. So you can either use timestamp or time travel. You can use either timestamp or snapshot version to perform the time travel operations, right? So for Hive and Impala, as you can see, the SQL syntax are almost the same, are the same actually. So this is really, try to give you the ease of use, whether you want to switch between the Hive or Impala engines. You can, just switch, with and without having to rewrite some of the SQL syntax. And certainly you can pick your own favorite compute engine for time travel operation as well. So whether you want to use Hive or Impala and Spark, which is really highlights the openness of this table format. So next, what I want to do is actually talk about the what we call in-place partition evolution, right? So in general, partitioning is just a way to, I would say, group items of a certain type or values for faster processing. And partitioning in database is no different. So large table are, you can divide it into multiple smaller tables by grouping smaller rows together, right? And of course, why do we want to do that? Is the benefits is, you want to enable faster reads and the load time for queries that access only part of the data. Now, Iceberg makes the partitioning simple for the user by implementing a feature called a hidden partition, right? Rather than forcing the user to supply a separate partition filter at the query time, and Iceberg actually handles all the details partition and the querying under the hood. So user actually don't have to maintain the partition column or even understand the table physical layout to get accurate query results. The Iceberg actually have several partitioning options, right? So user can partition the timestamp, by year, month, and day and hour. And the Iceberg keep tracks of the relationship between column value and the partition without requiring some additional columns. And and this Iceberg can also partition column values by identity, hash buckets, and the truncation as well. So another benefits of hidden partitioning is that the user do not need to supply partition layout information when querying Iceberg tables. So there's a nice concept within Iceberg is something called a split planning. So just like example here in the screen is that if I want to do if I want to do partition evolution and let me change my the partition schema, right? In this example, of course, is from month to day, right? So before January 1st, all my data is partitioned by month, and after that would be partitioned by date. So when I do query planning, there were two separate plans, right? Any data sets that before January 1st, all those query planning were based on the month, and after that will be based on the date. So you have two sets of query planning in the query plan. So this is the notion of the split planning. So split planning is one of the many Iceberg feature that are made possible due to the table metadata, right? So this is essentially another example of really give you the the separation between the physical and the logical. This concept actually, this is making Iceberg table very versatile and very user friendly as well, right? So some of the things that I want to say is that now in this example, when I do the partition evolution, a couple advantage of you can see is that first of all, you don't have to regenerate a table. Okay, so and this is especially very useful when you're dealing with a petabyte scale data, and there's no downtime, right? So when you try to regenerate a table, that there will be downtime for your system, and also because of I don't have to time my SQL queries against the physical layout of the table. So I don't have to rewrite my SQL queries because of my partition schema change, right? So this is a kind of ease of use features that really built into the Iceberg table format. So this is a lot of benefits that given how the partition is one of the key features that within Iceberg table format. So the next thing that, of course, I want to share with you is some of the partition. What we have implemented is the partition evolution SQL examples, right? So here the SQL syntax we have developed for partition evolution with the compute engines that we have integrated in our Cloudera Data Platform for the Iceberg table format. So in this example, you can see that the partition schema changed to hour. And so it's a very simple SQL syntax, right? So and for Hive and Impala, SQL syntax again are the same, and you can use them interchangeably. It depends on your familiarity with the with the engine, right? And you can also certainly pick your favorite compute engine for partition evolution. Whether it's a Hive or Impala or Spark, which really highlights again is the openness of this table format. Um, the next thing that I want to share with you is that I think we are, from a Cloudera perspective, we are providing a technical preview for Iceberg through our CDP integration, right? We actually, this is in a very high level in terms of set of features that you can actually try in our technical preview. If you're interested in any of those capabilities I'm highlighting here, please contact us, right? So again, remember there's a snapshot I was showing you earlier, right? A set of a very rich set of SQL commands, right? Queries, DDL, DML. You can try them all with all three engines I just mentioned. Compute engine interoperability for readers, writers. What does that mean? For example, if you want to use a Hive to do ETL, using Spark to do ETL, and then at the same time you want to use Impala to do the BI query reads, you can do that through our tech preview. So essentially, that's what we call compute engine interoperability, really enhancing the multi-function analytics that we're talking about on this Iceberg table format. And actually, Louise later on, I'm going to show you the live demo just based on that as well. Right, time travel operations, you can do that with all three engines, and also table authorization or fine-grained access control policy. You can also do that with our engine. Table conversion, right? You can do auto table commands I just mentioned in the Hive, and also table evolution, right? You can do schema evolution or partition evolution is all actually there as part of the technical preview. Now, as I mentioned, I want to talk about some of the emerging use cases, right? So some of the emerging the emerging use cases is based on all those technical features. So I want to actually up level this a little bit, maybe try to translate how you can actually benefit from the if you're analytics data engineers and all that, how can you benefit from this set of technical features? Number one, what I want to talk about is the reproduce machine learning models, right? So what does that mean? During the model training, data scientists very often want to run various experiments with different parameters on a given set of data. Now, when the data engineers try to revisit their experiments after set of time and try to reproduce the model, and typically the source data actually has been changed by some of the upstream pipeline, and they don't even know, right? And hence they unlikely they're gonna able to reproduce the same experiment. Now, in the past, the data scientists or data engineers, right, what they will do is they were actually creating multiple snapshots or multiple copies of data. Downside of doing that is, of course, you're going to increase your storage cost, you're going to increase your silo. And now with the time travel capability I just mentioned, you can actually going back in time based on the timestamp, based on the snapshot you are providing, you can actually you can reproduce the machine learning data sets that are required for the machine learning model. So this is a very nice feature that I would say a very nice use case based on the technical feature, which is the time travel. Now, second thing is the historical audits, and especially very true for a lot of the financial services companies that I've been running into, right? So very often is that they want to audit data changes. They want to know that so actually it's very critical to do any of the historical audits, financial audits, right? Both in terms of data compliance as well as just simply I want to do debugging to understand how data has changed over time. So organization moving from the traditional data systems to big data technology and in the cloud are really struggle with the scenario. But with time travel, this technical feature can really help you with historical audits. I can always go back a time and then try to figure out who did when and what, right? So this is essentially you can do for the historical audit through this technical capability. Next thing is the rollback, right? So this is also important. Think about the data pipeline sometimes can write the bad data, right? And I have a bad job run or bad ETL, and then producing the bad data for the downstream consumer. And this could be, maybe something wrong with my infrastructure. One of the nodes, goes wrong, and also just mess up all my data, or maybe one of the algorithm I'm putting in mess up all my data, right? So for the what we can do is in this case again take advantage of this time travel capability. I can always roll back to a state based on timestamp I provided or snapshot that I provided. I can always rolling back to a healthy state of the data sets. So this is again, this is a rollback capability and also really take advantage of a time travel that is a technical feature that I mentioned. So Louise will actually perform live demo now to illustrate the multifunctional analytics capability with Apache Iceberg and with our Cloudera Data Warehouse, which has Hive and Impala compute engines, and Cloudera Data Engineering, which has a Spark compute engine. What Louise is demonstrating today is what's available with our Iceberg technical preview. So with that, Louise, take the floor.
Perfect. Thanks, Bill. Thanks, everyone. So let's start. Okay, let's set up the contest here and how I planned the demo for today. It's pretty simple. It's a simple scenario. This is a data set that we already deliver within our platform, which is composed by a star schema model and a data set that contains data from the airlines delay connections and flights from some years until 2008. This is the fact table, the flights table, which we loaded already as CSV into your object storage, and we will convert it. We have two possible ways to convert it, as Bill said. Actually, we will create a new Iceberg table from this data set and also create the dimensions tables so we can start seeing the new nice features that Iceberg bring to us. So let's start. I use Cloudera Data Platform for this. First, loading CSV tables from Cloudera Data Flow. And now I will use Cloudera Data Warehousing to create the new Iceberg tables. I already created the CSV mapping between external tables to the files that we have already loaded. So I just will guarantee that I will drop the current database if it still exists, create the new database and the new Iceberg tables. And here you can already see some of the contribution that we are doing into the open source ecosystem. This story stored as Iceberg table, which will basically instruct Impala to store this table as an Iceberg format. So let's execute all this. It's pretty fast. Even that the dimension table, the flights table has around 86 million rows. So this last one will execute in some time, but it's not too much. Actually, in a matter of seconds, we will have all the tables already converted to Iceberg. And this is around 15 gigabytes total. And it's almost done. As I said before, I could have also convert this table direct to Iceberg, but as a demo, I will need to reproduce on the other sessions that I will have. I will maintain the CSV tables and we'll create a new database with the Iceberg ones. Here, have ever created. The last one we inserted 86 millions of rows. Sorry, I had a problem with my headphone. And right now, I can start querying those tables already. For example, this last one, which is created in Iceberg. Already contains the data from the CSV file. So I can query this table already. And also start doing my analytical analysis, etc. The second thing, after I already converted my historical data, I can try to create an ingestion pipeline into the table. So I already did this. I created a Scala script to use within Spark to simulate new data into this table and insert this table, insert new data into this table as well. So I have a job here in Cloudera Data Engineering ready to start this this pipeline. I didn't schedule this job, so I will run manually right now. But before doing this, let's see how easy also it is to change the partitioning of this table. Right now, this table is not partitioning. And as Bill said, it's common use case, you change the partition if the access path of the table changes during the time, or if you identify that a partitioning would be good for all the users and queries that you are executing it. So this table, just to confirm, I did create it as a partitional table. So here, the create table doesn't show that this table is partitioned. It's just stored as Iceberg, as we saw before. And also I can see that the data, it's until 2008. I didn't load any new data right now. And the idea, it is to alter this table to set the partition spec. And this is another new SQL DDL syntax that we are already introducing to our platform because of Iceberg. So you can easily change the partition of the table without rewriting this table or the need to move the files between the storage. So this offload the burden to control the files, the metadata, and also the partition information from the metastore, because all this information will be stored in the manifest files into the storage, because Iceberg works in that way. So right now, if I do the show create table again, I can see that I changed the partition by year. So this is pretty much how easy it is to change the partition of the table. And the old information, or the information that I have into the table before the partition,
before altering the partition, we will still be on partitioning. It won't follow the new partition that I've changed. Only the new data will have this partition spec by year. And the new data that is coming, I will be possible to join between the two different partitions that I will have right now in the table, mainly because, as Bill already said, we will split the plan between those two partitioning strategies. Okay, so if I go back to Cloudera Data Engineering, I can see that the job already started and already start processing my ingestion pipeline. Cloudera Data Engineering, it's a full managed Spark that you can create full data engineering, end-to-end data engineering pipelines. And after you create your pipeline, you can also schedule with Apache Airflow. You can schedule your job and also create another pipelines, processing pipelines to not only ingest the data, but also perform ELT, start load and transform into your storage and tables that you already created. So this should be almost ready right now. It's a pretty quickly job that will insert almost 7 million of rows. So let's see if it's already done. As I said before, I showed before, it was, I had data until 2008. So now I should have already the 2009 data. And if I run again, I will have 2010, etc. But it's a simulated data. I won't do this. And I've ingested 7 million more than 7 million rows on this table right now. And this new data has the new partition spec. So just to prove this, I can see the files directly in the object storage that this table is being used. And I will have the files that is on partitioning. And also we'll have the files. It's almost 100 files with the year 2009, which is the data that we just inserted and processed using Spark, using Cloudera Data Engineering, and ingest this data right now into this table. So for the schema evolution, it's pretty much the same. It's pretty easy. All the information will be stored in the manifest file, as Bill said, and the engines will use this file to make the plan and see all the metadata of the table. And this, as I said, offloads the burden into the master metastore to be responsible to define the table specification, etc. This will be under the storage and under the Iceberg APIs directly. After this, after we run the Spark job, we can go directly to the time travel and snapshot of the table to see the table evolution during the time. So here it's another SQL that we developed. So you can see the history of these flight tables. We should have only two snapshots right now. The first one is the table that was created. The second one, it is the Spark process that ingested and processing new data. And I can see and perform time travel between the time and also between the snapshots that we have here. So I will use this snapshot first. If I do this count into this table, I will have the 2009 data, but using the old and the first version of the snapshot, I should have only the until 2008 data, which is the one that I have right now. This is very useful for audits to reproduce the same results that you may have to do within your machine learning pipelines, within your audit procedures that you may have internally. And this is pretty, or at worst case scenario to recover data after a bad process that you did. So this is very useful. And just to show the last snapshot, it should be the same one that we have without the query. And here, the parent ID identifies the before and after of the snapshots. I can see pretty easy the 2099 data here. Okay. Now we show time travel. We can run analytical queries, and just to show the performance of the platform, and also Apache Iceberg under the covers using open source formats. Apache Iceberg, as Bill said before, it's a table format that can use RC, can use Arrow, can use Parquet, all in an open source format, and it's decides for the engine and leaves for the engine to have the performance features. For example, Impala have vectorization already working with Parquet, already have clustering, etc. The same as Hive, the same as Spark, and because under the covers it still uses Parquet, it still uses ORC, etc., it will benefit from these performance features already. So here I have a full scan query on the tables that we have just created. Notice that we didn't collect any statistics. It's not the best practices, but so let's execute as is right now. The first one is to find all the international flights where destination is not the same country. So for a flight that is going to another country, and here we have already the results. The same thing, and this is a more heavier query because we are joining the dimension 2 times without a where clause. So we are performing full scan on those tables. And also notice that we are joining between the 2 partitions that we already changing within the table and ingested, processed. So here we also have the results here. And the last one, the number of passengers and this one it is more restricted because I am using this where clause to just have the results from the DL carrier, and the number of passengers that missed the connections and have a long layovers because of this missing connection as well. So this also it's a pretty fast query, and also because the files and the metadata it's on the storage. Even the most restrictive query, as we are seeing here, will be processed fast as the analytical ones. So in a matter of seconds, we will have the results here. Perfect. Now we have all the analytical queries. We can also share these tables, these results with machine learning jobs, etc., with Spark jobs and other full data pipelines that the platform provides. One most important thing, it is security and governance, right? So the community of Apache Iceberg, it is working tirelessly into performance and to bring new features as it's one. And also, it's working within engines integration. So Cloudera provides not only engine integration, but also a full, complete set of security, auditing, masking, for filtering, and governance features within the platform. And because of the open source nature of the platform, it was pretty easy also to integrate within our Cloudera SDX, which is composed by Ranger and Atlas, where, for example, I can pretty quickly define a new policy. Let's suppose this field, this column, tailnum, was a PII or a column that I want to mask the data that I have here. So pretty simple. I can go here in Ranger. I already have this policy ready to go, but it's disabled right now. I will enable it. So it is disabled. I will enable. And the same thing to filter the data to only see the B6 airline row. So if I go back and query this data now from this column, I will see the masking policy already in action. I've created the masking policy to be null, to nullify the data. And the same thing in the row level filter. I will enable it for the same dimension table that I have. And here it is the filter that I'm doing. Unit carrier will be only B6 for my user. It can be a group of users or even tagging policies I can create here in Ranger to have a more refined policies. And now, after it will propagate to all the engines, and now if I try to select data from this table, I will only have B6 unicarrier. Yeah, just to confirm. You can see here. That I will only see the B6 data from this table right now. And the last thing, that after all the pipeline, the ETL that you created, the Spark jobs, and we can show the interoperability between all the engines that we have already integrated with the Spark. This is everything ready right now in the platform. We can give to the users and the business users, and the most important, that will benefit from this data, a very nice dashboard, and that will show the data within the airlines data set that we created before. Here, I can see only the data from the B6 already because I just applied this policy. And the user can also filter the data between the data sets. I'm joining the data in this data set to see the airlines, the planes that we have, and the record count of the number of flights and the most delayed flights, and the most airlines that didn't have delays during that time. Well, that's it. Hope that you like it. It's a pretty simple demo just to show the power of Iceberg right now. Thank you very much. Back to you, Navita and Bill.
Thanks, Bill. Thanks, Luis, for a wonderful presentation and a great demonstration. It was nice to see all the capabilities and benefits of Iceberg and then see them in live in action with the demonstration. Let's move on to the questions now. I want to remind the attendees again that they can enter their questions through the chat window on the respective platforms that they have joined from, and we'll try to get to all the questions today if possible. So let me start with the first question. So this has been asked by multiple people. What are the comparatives to Iceberg? So like Delta Lake, Hoodie. Can you speak a little bit more on these other data platforms and the differences between Iceberg and those other table formats?
Yeah, so this is actually a very good question, and this is actually going back to why we actually pick Iceberg. to integrate with our Cloudera Data Platform, right? So like folks saying that there are Delta out there, there are Hoodie out there. Why do you actually pick Iceberg? This is going back to what we mentioned earlier, actually in the first slide of the presentation, is that we're seeing that Iceberg is 100% open source, right? And also we're seeing very strong open source community support, and also growing set of a compute engine also supporting the Iceberg table format. So community support, industry about adoption, and 100% open source. Those are the main reason that we actually pick Iceberg over other table formats to integrating with our Cloudera Data Platform.
Sounds good. Okay, there was another question around which version of Iceberg is supported in CDP.
So that's also a very good question. So based on our development, we just rebased our development platform to 0.13. So that is the latest. That is the version that we just rebased.
Okay. Okay. All right. And the next question is, does time travel support permission or grant changes? Are permissions stored along with snapshots in Iceberg?
Sorry, can you repeat the question again? Did not hear. Yeah.
Sure. So this question comes from Alex. He's asking, does time travel support permission or grant changes? So basically, do permissions also get stored along with snapshots in the Iceberg tables?
Yeah, so this is actually going along what we are talking about because we do have the integration with Ranger, right? And so this is actually given the fine grained access control. So we will actually take a look at what authorization rights that you have based on the snapshot of the time that you are actually going by. So this is supporting in terms of fine grained access control.
Sounds good. All right. The next question is, so you said that Iceberg supports multiple query engines and multiple engines. With CDP, we are supporting Hive, Impala, Spark. Is there any guidance from Cloudera on when to use which engine over Iceberg?
Yeah, so this is actually also a very good question. Is that we know that there are a lot of our Cloudera customers are using those existing engines. So for example, they are using Hive engine for SQL-based ETL. They are using Spark for a very programmatic way of ETL. So using Java or Python, right, to do the ETL, and they're using Impala to do the BI query engine. So what boils down to is that what engine you're using for what job based on your existing workflow. We're not forcing you to change any of the existing workflow that you have. And what we're helping you is that just by swapping out the table format underneath of your compute engines, so that this is really give you the flexibility that based on your own familiarity of the compute engines that you have today.
Okay. Okay. And then, Luis, this question is based on the demonstration that you did. The question is, it's I think this is from Dheeraj. He's basically asking, will it create two different execution plans while working on split partitions?
When working with different partitions, the split plan will be in the same plan from the query that will be executed. So the engine will see that the table has the partition spec altered, and will do the split plan within the same plane, the same code engine in Impala, or the same plane in Spark, etc., in one execution. So we'll not execute two times. In one execution, we'll perform this split plan.
Okay. And then in continuation, does Iceberg work on CSV files?
Yeah, so let me take that quick question. So right now, based on the Iceberg spec, is that the file format it supports is of course Parquet, ORC, and the Avro. So those are the file formats that are currently specified by the spec. But I would imagine that based on the growing popularity of Iceberg table and the other file formats support just a matter of time.
Okay. And then again, on the demonstration, do you need to compute stats on newly created tables, or does Iceberg handle that?
Iceberg handles the basic stats. For example, the min and max number of rows for each partition, for each column, etc. And if you want a more defined stats, for example, the median and so on, yes, you need to compute the stats, which is normal for all database or data engines in the market.
Okay. Another question is support for GCP's BigQuery and AWS's Athena external table integration on the roadmap for Iceberg? So the question is from Tigrin. He's saying, is support for GCP's BigQuery and AWS's Athena external table integration on the roadmap? Because it seems Tigrin is a consultant who has clients using GCP and AWS.
Yes, we have external JDBC support. For Iceberg today, as Bill said, it is being used from other ecosystems as well. AWS just announced that it's being integrated within their platform. The same other companies. It is possible to read external tables and integrate with the platform. It depends of the use case that he's saying.
Yeah.
Basically.
And also through the data federation capability, you'll be able to federate your supporting the, for example, GCS or supporting other JDBC compliant data sources through the query federation perspective.
Okay.
Yes. Just one more note on this. If the question is to offload the data between those platforms, in our platform, we delivers connectors, Cloudera Data Flow, to read the data from those database, and it's possible to create the pipelines to convert into Iceberg as well.
Okay, got it. Luis, would it be possible for you to show your screen again, the demonstration screen again? Because there's a question where Dheeraj is asking, can you show execution plan as how data files are getting pruned by Iceberg?
Yes. Let me show here. Let me go to the analytical queries here. I have the jobs that I already executed. Let me see if I have the one. Let me do the explain direct. It's better. Okay. Sorry. Didn't execute it. Okay. So we can see that Impala already planned this query, and is showing that the table it doesn't have the statistics that we have, but it is scanning the partitions, the files, the number of files, and then doing exchange or broadcast of the dimension tables that he defined as the dimensions. So basically, it's the tables that have less amount of data than the dimension one that we are having. Here, the table the naming table is flight, so it will do the broadcast of the airports table between the plan. And then we can see that is doing an inner join between those broadcast tables into the flights table. So the number of rows, of course, during the stream process uh, will will be more than the normal, because it doesn't have the statistics, but it is sorting by the number of the rows that we have, and also the order by and the day of month. Basically, this is the plan. The filters that we have here will be in the runtime, and the expressions and the join the table is doing by Impala here, but Spark or Hive will do a different way to do this as well.
Also show the directory structure on data nodes.
Sorry, I didn't hear.
Can you also show the directory structure on the data nodes?
The direct structure on the data nodes, we don't have data nodes here. Basically, we are using the object storage to store this data directly. So there's no data nodes per se, but I can show the data here that is storing directly into the storage. So here is the data that is stored in Parquet from this table that we have created. This is the Iceberg table, and I can see here the manifest files that is being created as a metadata. So because it's Iceberg, we'll have all the information of the partition evolution, the schema evolution here. And basically, we are connecting Impala directly into this storage without the need of data nodes.
Today and all the time we have today. If there are more questions, please enter your questions on the chat, and we'll collect them and maybe try to answer them offline. Thank you so much, Will and Louise, for your time today. I am just going to go back and to our resources page to tell our audience about the Cloudera user space that they can go to see more videos, tutorials, and get more information about events, read some blogs about Iceberg. You can see how to use Iceberg table format and CDP public cloud to ingest, process, and analyze your data. Also, there is a blog that we posted recently on 5 reasons to use Apache Iceberg on Cloudera Data Platform. I highly encourage you to go and read the blog. We also have a survey that we would be sending out to some of our participants. Please be kind enough to respond to the survey. Your feedback is very valuable to us. We'll take a note of your comments so we can incorporate them in the upcoming future of data meetups. And then now let's move to the raffle, which is definitely the most exciting part of this meetup. So all those, thank you everyone who answered, who sent in your questions to our guests, and also those who entered some comments. We've got a list of all these people here, and I am now going to click to spin, and let's see who is our first winner. So, yeah, that was very close. Congratulations, Human. Thank you so much. You are our first winner, and as we mentioned, you will be receiving a lot of Cloudera swag. So congratulations. And let's spin the wheel again for our second winner. All right. So congratulations, Vivincius. You are our second winner, and we will be sending you swag, Cloudera swag, so you can, yeah, just remember to send in your email address, and we will definitely send you some exciting swag from Cloudera. So send your email to socialmedia@cloudera.com to receive your prizes. And this concludes our meetup for today. I would like to thank our speakers again, Bill and Louise, for joining us and taking us through Iceberg, its capabilities and benefits. And I would also like to thank Emma and Bill, who are at the backstage helping us produce this event for today. On behalf of the entire team, I would like to thank you all for joining us today and hope to see you again on our next Future of Data meetup. Thank you.